How a ground source heat pump works for commercial buildings. Geothermal avoids the need for outdoor equipment, reducing vandalism and liability. Why geothermal heat pumps? Free and renewable source of stored energy from the ground. Savings up to 70% for heating, cooling, and hot water. Quiet and enhanced comfort. Reliable and environmentally friendly. Install geothermal heat pumps. Lutheran Church, Metropolitan Housing Trust, John Deere dealership. Operating unit inside and heat exchanger loop is underground, no external compressor. Low operating and maintenance cost, 25 to 50% less than conventional system. Ground source heat pumps are among the quietest ever designed, similar to a refrigerator in sound. Geothermal has no flame, no flue, no odors, and no danger of fire or fumes, and a long life. Here we see the heat going into the ground. Here we see the cool coming out of the ground. You have natural dehumidification. Heat one zone or room and cool the other at the same time. Less space for equipment, more space for offices or storage. Geothermal systems deliver even space conditioning year-round. You can get heating, cooling, and domestic hot water, 3 important benefits from a single compact unit. It's dependable, reliable, long service life, ground loop warranties of 50+ years. No boiler, or tower, significantly reduce full-time maintenance staff and eliminate boiler maintenance. Eliminate the chemical and other costs associated with the prevention of scaling and bacterial growth. Eliminate year-round tower operation that requires a lot of expense, especially during the colder weather months. Low source energy use and low air pollutant emissions. It's a green technology. How do you get Earth's energy? Well, we get the Earth's energy from the sun. It's 19% is absorbed by water and vapor and dust, 4% absorbed by clouds, 17% reflected by clouds, and about 6% reflected by the surface. You have about 46% absorbed by the ground. The Earth is like a solar battery, absorbing nearly half of the sun's energy. The ground stays a relatively constant temperature through the seasons, providing a warm source in winter and a cool heat seat in the summer. How do you get Earth's energy? Well, Earth absorbs almost 50% of all solar energy and remains at nearly constant temperature of 50 to 70 degrees, depending on geographical location. Heating in winter, water circulating inside a sealed loop absorbs heat from the Earth. Here it is compressed to a higher temperature and sent as warm air to your indoor heating system for distribution throughout your building. Cooling in the summer, the system reverses and expels heat from your building to the cooler Earth via the loop system. This heat exchange process is not only natural, but is a truly ingenious and highly efficient way to create a comfortable climate in your building. This is how the Earth works to save your energy for cooling. This is how the Earth works to save you energy during the heating cycle. Parts of a ground source heat pump system. You have your ground loops, called a geo-exchange. And they're either closed loops, which is the most used, or open loops, like you might find on lakes or wells. Here you have a heat pump, and there's different types. There's water to air heat pumps, and there's water to water heat pumps, which are for floor heating, and it's called hydrodynamic. You have a distribution system in your building, similar to what you do on conventional systems with ductwork. And you have the hydronic water in the piping in the floor as another means. Here we have closed ground loop system, trenching, horizontal loops with 1 or more pipes and loops 4 to 6 feet deep. Or vertical boring. Vertical loop bore hole with one pipe downhole looping back to the surface. This you can use in restricted space. Or directional boring, a horizontal loop that can be under a building where you have limited space. A closed lake or pond loop system. Lake or pond loops in water will require some horizontal trenching from the house to the pond or lake. Lake level must be sustainable during dry season and at least deep and large enough to maintain temperature during drought periods. Here we have an open ground loop system. Groundwater must be available at a reasonable depth and temperature. The groundwater is pumped from the delivery well to the heat pump and from there to the sink well. Several heat pumps within a building can be in the attic space. You have water to air heat pump for duct heating and cooling. You have de-superheaters for hot water. And you have quiet and outstanding comfort. Here you see the ductwork in the attic. You see the heat pump. And you see the constant temperature being circulated from the water from the loop system. Here you have your ductwork shown in the attic, where you have warm or cold air blown through the ducts. You can have various rooms with zone control and or remote master control, one room heating and another room cooling. You have outstanding comfort. Here you have the hydronic systems. Its use is to use water-to-water heat pumps, providing warm water distributed in the floor. You can have room zone control, outstanding comfort. When your feet are warm, your body feels warm too. Cost and payback. Ground source heat pump system will cost more than a conventional system, but payback will usually be 2 to 8 years. This is according to the U.S. Department of Energy. How much more depends on where your building is located and which ground source heat pump system you use. Cost depends on available contractors who are accredited installers in your area. Open loop systems do not require some specialized contractors, such as drillers and trenchers, and are less affected by this problem. According to the Geothermal Heat Pump Consortium, the current impact of geothermal heat pump technology is equivalent to taking over 1.1 million cars off the road, planting more than 300 million trees, reducing U.S. reliance on imported fuels by 20 million barrels a year. The Emergency Economic Stabilization Act of 2008, H.R. 1424, the bill extends tax incentives for the installation of highly efficient heating and cooling and water heating systems such as geothermal heat pumps until the year 2016. A one-time tax credit of 30% of the total investment up to a maximum credit of $2,000 for all residential ground source heat pump systems installations. A credit of 10% of the total investment without a maximum credit limit for a commercial installation. To qualify, the systems must meet or exceed Energy Star requirements and be installed after December 31st, 2007. Ground source heat pumps have the lowest life cycle cost of any HVA system available today. Is considered the technology of choice by the Department of Energy and the Environment Protection Agency. Will normally cost about 25% more than the least expensive rooftop units or split systems that are available, but will pay back that 25% extra cost between 2 and 3 years. Ground source heat pumps provide the following advantages: best regulated comfort, lowest maintenance and longest equipment life cycle, reasonable first cost, lowest energy cost, adaptability to new and retrofit design. More information can be obtained at www.igshpa.okstate.edu.